between atoms, elements, mixtures, and compounds. Now let's start with atom. Atom is the smallest particle that makes every matter. So anything that has space and occupies volume is a matter, and that will be made up of atoms. An atom consists of subatomic particles, electrons, protons, and neutrons, and it is these atoms that combines to form elements, compounds, and mixtures. Now let's look over what are elements. Now elements are those substances which are made up of only one types of atom. Now there are more than 100 different elements and each have different properties. Like gold is shiny, whereas gold is solid, whereas carbon is an element which is a solid, but oxygen is a gas. So every element has different properties and they can be categorized as metal, non-metals, and semi-metals. And where do we find all the elements? We can look over all the elements in the periodic table, which represents all the known elements in the order of the increasing proton number. So we'll be looking next in the further videos what is a periodic table and what information it gives us. Next is mixture. Now mixture is something, if you just mix sand and water, you mix salt and water. So these are the two substances which can be two different elements or compounds which are just combined without any chemical reaction. So in mixture, all the components retain their properties and you can easily separate them by physical means like salt and water, sand and water, oil and water. On the other hand, when two elements or atoms, they combine together via chemical bond and each element do not retain its property, like methane is one carbon and 4 hydrogen atoms joined together, and the properties of methane is completely different from carbon and hydrogen. So this is what a compound is. So compound has a completely different properties than its constituent elements. Okay, so I hope now you are clear with the difference between atom, elements, mixtures, and compounds. Now, where do you find the periodic table? You find the periodic table, all the elements arranged in the order of the increasing proton number. So hydrogen has a proton number 1, is placed first, followed by helium, lithium, and beryllium. And you can see this periodic table in the forms of groups and periods. So these vertical columns are the groups and these horizontal rows are the periods. And if you look at this, we draw a zigzag line on this periodic table. All the elements to the left of the zigzag are all metals and all the elements to the right, which are colored yellow in this image, are all non-metals, and the ones which are there in the zigzag are the semi-metals. Semi-metals or the metalloids have the properties which are both metals and non-metals. Now, elements in the same group, like group 1 and group 2, all have similar chemical properties because they have same electrons in the outermost shell. So group 1 will have 1 electron in its outermost shell. Group 2 will have 2 electrons in its outermost shell. Okay, so just by looking at the periodic table, there are a lot of information you can get to know. Like lithium and sodium, they all belong to the same group. They have 1 electron in their outermost shell. Magnesium and calcium will have 2 electrons in the outermost shell. If anybody asks you, give an example of a metal, you can give any example from this group. If somebody asks you name a non-metal, you can give anything from this group. And the last is the group 8 that are noble gases. Noble gases means they do not react. And we look into the subsequent videos why they do not react. So this is just the basic of periodic table. Just by the glimpse of the periodic table, what information you can get. Next is, you have seen a lot of chemical equations. So you can see in this chemical equation, there is carbon and there is oxygen. So 1 mole of carbon, what does the chemical equation tells you? The chemical equation tells you that there's a symbol, carbon, oxygen, carbon dioxide. 1 mole of carbon reacts with 1 mole of oxygen, forming 1 mole of carbon dioxide. Now, you can further refine this by putting the state symbol. State symbols tells us that at the room temperature, what is the physical state of these elements. So carbon exists as solid, oxygen exists as gas, carbon dioxide exists as gas, and if there's a symbol that has liquid in it, generally we use it for water. That means it's liquid. And if there's any element which is in solution, we use the state symbol aqueous. So in chemistry, you should always develop a habit of writing a balanced chemical equation with the state symbols. Okay, so as we'll do different equations, we'll try to use the state symbols in them. Okay, now balancing equation. Now, balancing equation is based on the principle of law of conservation of mass. Now, what is law of conservation of mass? That the mass can neither be created nor destroyed. So there are equal mass of reactants that are being reacted, and the mass of the products will be equal to the mass of the reactants. So now let's look at this question. Can you see there's carbon and oxygen and CO? How many atoms of carbon are there to the left side? There's one. And to the right is also one. But how many oxygens are there to the left? There are two. And to the right, oxygen is just one. So to balance it, always remember, you add the number in the front. So we'll put 2 in front of CO. So that makes the oxygen atoms to be 2. So now our oxygen is balanced, but now it has disturbed the carbon. Now carbon is 2 to the right and 1 to the left. So we'll write 2 in front of the carbon as well. And now this equation is actually according to the law of conservation of mass. There are 2 carbons and 2 oxygen to the left, so means it has the same mass, and 2 carbon and 2 oxygen to the right means it has an equal mass of products and reactants. Now always remember, this law of conservation of mass is only valid if the reaction is carried out in a closed system, because if anything escapes from the mixture or the reaction mixture, then the product mass will not be balanced with the reactive mass, and this law seems to get broken down. Okay, so you need to remember law of conservation mass is equal number of reactants and products, and you write the balanced chemical equation showing the equal number of reactants and products on both sides. Next is a very important question. What is a difference? What are the differences between compounds and mixtures? Now here I have tabulated the differences between compounds and mixtures along with the bases. So compounds have fixed composition. So if you talk about water, there'll always be 2 atoms of hydrogen and 1 atom of oxygen. In mixtures, you have variable composition. You can put any grams of sand mixed with any grams of any volume of water. Compounds cannot be separated by physical means, but mixture you can separate by physical means, like you can do evaporation, crystallization, filtration. In terms of properties, the compounds has different properties than its constituents. For example, if we talk about water, water has completely different properties from its constituents, hydrogen and oxygen. In mixtures, all the components retain their property. Next is the presence of chemical bond. In compounds, the components are chemically bonded, but they are not bounded in a mixture. The chemical reaction takes place in the formation of compound, but no chemical reaction takes place in the formation of mixtures. In terms of melting and boiling points, the compounds have sharp and fixed meltings and boiling points, where mixture do not have fixed meltings and boiling point. Example of compounds is water. You can see it's 2 hydrogen, 1 oxygen. Methane, 1 carbon and 4 hydrogen. Hydrogen chloride, 1 hydrogen and 1 chlorine. Whereas mixture could be salt and water, sugar and water, oil and water solution. Now we know that the mixtures can be separated by physical means. Now let us look at what are the different ways we can separate the mixtures. Now there are 5 techniques you need to be aware of. First is filtration, which is used when you have a mixture of solid and liquid where solid is insoluble. So solid is insoluble in a liquid, so you can easily filter it off and solid can stick to the filter paper. Example, sand and water. In the crystallization, again, you can separate a solid and liquid, but in this case, the solid is completely soluble in the liquid. Okay, for example, salt and water solution, sugar and water solution. Next is distillation. Distillation can only be used when you have solid and liquid. Where solid is soluble, you can also use crystallization, but in crystallization, the liquid is lost. It is evaporated. But in distillation, you can collect the liquid, or you can take 2 liquids which has different boiling points. Next, you have the fractional distillation. Fractional distillation is mixture of liquids where the boiling points are close together. Example, ethanol and water, or the mixture of crude oil. Or chromatography, where it's different components in a solution. For example, components in an ink. Now, these are the 5 techniques that we need to know for your paper 1 chemistry: the filtration, the crystallization, distillation, fractional distillation, and chromatography. Now, let us look at each one of them in detail. The first one is filtration. You must have seen this setup in your school laboratory where you have a conical flask which is placed on a glass tile, and then you have this filter funnel. This filter funnel looks like something like this with the tapering end, and inside it you place this paper, which is a filter paper. Now you pour your solution of a solid and a liquid through this filter paper. the solid component, which is insoluble in the solution, will stick to the filter paper, and the runoff will be the soluble solution, and which is known as the filtrate. So the solid component can be separated from a liquid using this technique. The solution runoff with soluble component and insoluble component like sand stick to the filter paper as a residue, and the runoff is the filtrate, which can be water or the solution with the dissolved components. And if it is just water, then you have your solution separated. If it is a water with any dissolved components, then you can do another technique to separate this mixture, which comes off as a filtrate or the runoff liquid. Now, the second technique which is used to separate the solid and the liquid with the solid completely soluble in the liquid is a crystallization or evaporation. So this is a setup that we use. We take a water bath and we heat the mixture in this water bath. And let's suppose it has a solution of salt and water. We will heat this mixture, all the water will get evaporated and the crystals of solid will start forming. So you have your solid components separated from the liquid. Next is the distillation technique. Now, in the previous technique, you can see that the water has been evaporated. But if we do any mechanism in which we collect this water vapors, condense it and collect it separately, then in this way, we can get both of these components. So the next technique is distillation. It can be used for a solid or a liquid, or it can be used for the mixtures of two liquids which have the different boiling point. You heat the mixture. One of the component which has the lowest boiling point will evaporate. Once it evaporates, it collects in the condenser. The condenser cools it, and then you can have this component separated in a separate beaker or any flask. So distillation is used to separate solid and liquid, in which solid is completely soluble in the solvent. It can also be used to separate two liquids which are completely miscible in each other and have different boiling point. So in evaporation, the solvent is allowed to evaporate, leaving solid behind. But in distillation, solvent is evaporated and the vapors are passed onto the condenser, which cools the vapors and collects the solvent in a separate container. In case of separation of two liquids, the one with the lower boiling point will evaporate first and will be collected by the condenser. Okay, so now is a fractional distillation. Now, let's suppose you have the mixtures of more than two liquids, like of crude oil, or you have the mixture where the two boiling points are very close to each other. So in this, what we do is we take a fractionating column. So the vapors which pass to the condenser, they first pass this fractionating column which have glass bead in it. So the round bottom flask is fitted with a tall fractionating column with glass bead which is connected to a condenser. The vapors first evaporate into the fractionating column and hit the glass bead. The lower boiling point liquid will travel high up the column and reach the condenser and get separated in the separated flask. And the high boiling point liquids, they hit the glass beads at the bottom, get condensed, and it will come back to the flask. Okay, so I hope this technique is clear to you. You should know this setup. It's a fractionating column with glass bead. There's a round bottom flask. There's a Bunsen burner. There's a condenser which collects the lowest boiling point solution. Next is chromatography. Now, chromatography is a technique in which you separate the components in a mixture on the basis of their solubility. So I think you must have done this experiment in school. You take a chromatography paper. On this, you mark a line with the pencil and you dab the solution or a mixture that you need to separate. And then the solvent is allowed to run up. As the solvent passes the mixture, it will dissolve all the components inside it, and the components of the mixture which are more soluble will travel up, and the components of the mixture which are less soluble in the solvent will give a mark at the bottom. So in this figure, you can see that the yellow components are more soluble, so they traveled up, and then the red components are less soluble. Okay, so the components of the mixture which is more soluble will travel at a greater distance and will leave its mark near the top, and the component which is less soluble will have a mark near the bottom. Okay, so I hope all these 5 techniques are clear to you. You should be clear with where we use them and what is the process of doing this technique. Okay, so I hope this unit is well clear to you. Now let us look at what are the important key terms that we studied in this unit. We talked about atoms, elements, mixtures, compounds, periodic table, chemical equations, balanced equations, state symbol, filtration, crystallization, distillation, fractional distillation, and chromatography. What are atoms? Atoms are the smallest particle of the matter which contains electrons, protons, and neutrons. Elements are the substances made up of only one type of atom. Mixtures are the substances made up of two or more compounds which are not bonded chemically. Periodic table is a table that contains all the known elements in the order of the increasing proton number, increased in groups of arranged in groups and periods. Chemical equation shows a reactants and a product of a reaction. Balance equation shows equal mass of reactants and products in an equation. State symbol indicates the physical state of each element in its reaction, and thereof solid, liquids, aqueous, and gas. Filtration is used to separate an insoluble solid and a liquid using a filter funnel and a filter paper. Crystallization is a technique used to separate soluble solid from a liquid using evaporation. Distillation is the separation of components on the basis of boiling point. Fractional distillation is the separation of immiscible liquids with closer boiling points in a fractionating column on the basis of difference in boiling point. And chromatography is a technique used to separate the components of the mixture on the basis of their solubilities in a given solvent. So I hope these key terms are clear to you and you should remember them all. Now let's test yourself. You should name the technique used to separate the following: sand and water, salt and water, components of ink, mixtures of crude oil, and a copper sulfate solution. And then you have to label these ones as element mixtures and compounds: gold, water, carbon dioxide, sugar dissolvent water, and salt dissolvent water. And next is, how will you separate salt and sand? Okay, so you can pause the video, have a go at these answers. All right, so now let us look at the answers. So salt and water is separated by filtration, sand and water by filtration, salt and water by distillation, components of ink by chromatography, mixtures of crude oil by fractional distillation, and copper sulfate solution for crystallization. For salt and water, you can also use crystallization. Now, next is label as element mixtures and compounds. So gold is an element made up of only one type of atom. Water is a compound because it is two hydrogen and oxygen combined in fixed proportion. Carbon dioxide is also a compound which has one carbon and two oxygen. Sugar dissolvent water and salt dissolvent water is a mixture because these two components can be separated by the physical means and all the components retain their properties. Now, to separate salt and sand, what we can do, we can dissolve in water. The salt will completely dissolve in water, forming a solution, and sand will be solid. That will be there. We can pass this mixture to a filter paper. The sand will stick to it. We can take out the sand out of the filter paper, dry it. Now we are left with the solution of just salt and water. And for salt and water, we can use crystallization. The water will be evaporated, leaving salt crystal behind. Talk about the development of the periodic table. It took a lot of years to get the periodic table in the form which we have now. It started all around in 1808, where there was a scientist called John Dalton, and he published a table of elements, and he simply arranged the elements in the order of increasing atomic weights. There was no pattern, no similarity that was detected, so his idea was completely rejected. Then in 1864 came another scientist called John Newland, and he gave the Newland law of octaves. Now, what he did in that was he arranged the elements according to their atomic weights. And what he found that there was a similarity in the first element and the eighth element, like the octaves. Now, his idea was okay as it worked well up to calcium, but majority of the elements were not discovered at that time. So his idea of the first and the eighth similarity did not fit with all the elements. So that was also rejected. Then a biggest revolution came in 1869 when a scientist called Dmitry Mendeleev, he also arranged the elements according to atomic weights, but he found patterns of similarities within the elements because he left gap where the elements did not fit the pattern. So in this way, he organized the similar elements in the similar groups, and where the gaps were left, they gave us the pathway to discover the new elements. And using his idea, there were many new elements that were discovered. But again, that was not that effective because not all elements fit into that pattern. So argon, it was one of the shortcomings that argon, which had a relatively greater mass than potassium, should be placed before potassium. But if we do like this, then the argon will be placed in the group of sodium, and lithium and potassium will come in the groups of noble gas. So that is not a trend in the properties. Many other elements were also found not fitting this pattern, and Mendeleev swaps them in order to maintain the periodicity, but his periodic table was not universally accepted. Now, the present periodic table now overcome all these shortcomings by organizing the elements in the order of increasing atomic number or the proton number. So all the problems that were due to dissimilar atomic weights were all corrected by this. And when we created the elements in the form of atomic number, we came to know that the difference in masses of some of the elements is due to their isotopes, because there are many different isotopes an element can have, and the atomic mass is the average of the isotopic mass of all its isotopes. Okay, so this is how we came to this form, which is a present periodic table. Now, just looking at this modern periodic table, there are a lot of things that you can easily find out. First of all, from this group 13, we will make a zigzag like this staircase. All the elements that comes into the zigzag are metalloids or the semi-metals. All the elements which are left to that are all metals, and the elements to the right are the non-metals. So if someone asks you, give an example of any metal, you can pick any one from this group. If somebody asks you, give an example of a non-metal, you can easily pick any from this group. What is a metalloid? You can easily pick one in this zigzag. Now, the last group is a noble gas. Now, we'll see when we do the electronic configuration of the noble gas that it has full outer shell electronic configuration. As a result, noble gases are given the name noble gases because they do not react. The elements in the same group will have the same number of electrons in their outermost shell. So in the group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all of them have 1 electron in their outermost shell. Beryllium, magnesium, this whole group have 2 electrons in their outermost shell. This group has all 3 electrons in its outermost shell. So from the group number, you will get to know the information that these elements have these many electrons in the outermost shell, and if 2 elements have the same number of electrons in the outermost shell, it means they have similar chemical properties. Now, the next thing you need to remember from this periodic table is what are the common names of certain groups. Now, group 1 is known as alkali metals. We'll find out why they are known as alkali metals. Group 2 are known as alkaline earth metals. Group 7, that is whole of this group, is halogens, and group 8 or group 0 or the last group of the periodic table is a noble gas. And the elements which are between group 2 and group 13 or group 2 and group 3 are known as transition metals. Okay, now in the exam they can give you the periodic table and then ask you to give an example of a transition metal, a metal, alkali metal, noble gas, alkaline earth metal. So just looking at the periodic table, there's nothing to memorize in that. You can easily give the answer. Okay, now if you see, majority of the periodic table can be categorized into 2 classes of elements, the metals and the non-metals. Now you should know what is the difference between a metal and a non-metal. 2 differences I can easily make from the periodic table. There are a lot of metals than the non-metals. Metals are to the left of the periodic table, non-metals are to the right of the periodic table. Now let's look at what are some physical differences we see in metals and non-metals. When we talk about the appearances, metals are very shiny and lustrous like gold, platinum. The non-metals are dull in appearance. The position is metals are found in the left, non-metals are found to the right of the periodic table. Metals are good conductors of both heat and electricity. We'll see in metallic bonding that they have delocalized electrons, which make them very good conductors of heat and electricity. On the other hand, non-metal have no ions, no delocalized electrons, nothing to conduct electricity except graphite. So non-metals are considered as insulators. Then there are 2 very important properties, which is malleability and ductile. Malleable is hammering them into sheets, and ductile is hammering them into wires. So metals are malleable and ductile both. So you can hammer them to sheets and you can also draw them to wires. But you cannot do that for non-metals. So non-metals are not at all malleable and not at all ductile. Next, all the metals, they lose electron to form positive ions. We'll see in ionic bonding. And you also know that the metal has like 1, 2, or 3 electrons in the outermost shell, which is easier to lose. On the other hand, non-metals have more than 5 electrons in their outermost shell, so it's better for them to gain an electron. So they gain an electron and form the negative ions. Now, the density of the metals is very high, and they also have high melting and boiling points, whereas non-metals have a low density melting and the boiling points. Now, the examples of the metals are sodium, potassium, that is group 1, 2, and 3 elements, and non-metals are carbon, sulfur. So group 4, 5, 6, 7 are all non-metals. Okay, so now let us see, as I told you, the common groups, and you need to remember what these group number known as. So group 0, 1, 2, and 7 is what you should know. Group 0 is noble gas, 1 is alkali metal, group 2 is alkaline earth metal, and group 7 is halogens. Now, group 0, why is it called as a noble gas? Because they are stable, they have full outer shell, therefore they do not react. So what will be the properties of group 0? They are stable, unreactive, have full outer shell configuration, and are found in the last group, that is to the extreme right. Example, helium, neon, argon, krypton, xenon, and radon. Group 1 are alkali metals. We call them metals because they show all the metallic properties, and we call them alkali because they all react with water to form metal hydroxide, which is an alkali. Now, what are alkalis? Alkalis are the bases which can dissolve in water. So soluble bases are alkali. So what will be the properties of alkali metals? They are reactive. They have 1 electron in the outermost shell. They lose 1 electron to form positive 1 ion and gain full outer shell configuration by losing 1 electron. Example, list all the elements which are to the extreme left. And what are they? Lithium, sodium, potassium, rubidium, cesium, and francium. When we talk about group 2, these are alkaline earth metals. Alkaline, the reason is the same. They also react with water to form metal hydroxide. But why we call them earth metals? Because they're majorly found in rocks. And again, they have properties like the alkali metals. They are reactive, but they do not form +1 ions. They form +2 ions because they have 2 electrons in their outermost shell. So they lose 2 electrons to gain positive, to form positive 2 ion stable configuration. Example, beryllium, magnesium, calcium, strontium, barium, and radium. For group 7, it's halogens. Why we call them halogens? Halo means salt, gen means forming. So they are salt forming. They combine with metals and form salt. They have 7 electrons in their outermost shell. And as they have 7 electrons in their outermost shell, they just need to gain 1 more to have a full noble gas outer configuration. So they form negative ions. Example, fluorine, chlorine, bromine, and iodine. We'll discuss in a little bit more detail about group 1 and group 7 in this video. But all these halogens, they exist as diatomic molecule. So in the reaction, you will never see as F. You will see it as F2. You will never see Cl. You will see it as Cl2. Okay, so I hope this table is clear to you. This is very important. Make sure you remember the common names, which group they are in, why we call them with their names, and few properties of them. Okay, so now let's elaborate about group 1 and group 7 a bit. Now, when we talk about group 1, these are all the elements: lithium, sodium, potassium, rubidium, cesium, and francium. That is their symbol. You can easily see from the periodic table. And this is their electronic configuration. So lithium is 2,1, 281, 2881. Now you can notice all of them have 1 electron in their outermost shell. Therefore, they all belong to group 1. Okay. Now, their reactivity increases down the group because all these elements react by losing an electron. And when you go down the group, the tendency to lose an electron increases. Now, why it increases, we'll just find out. So if they'll ask you in the exam, which is the most reactive group 1 element, you can easily say cesium and francium. Francium is radioactive, but it is highly reactive. And then, which is the least reactive alkali metal? That is lithium. Out of sodium and potassium, which is more reactive, you can easily say potassium because it is down the group. Down the group, the reactivity of group 1 metals increases. Okay, now let us look at the physical properties of group 1. They are highly reactive. Their reactivity increases down the group. Since they have 1 electron in their outermost shell, they lose one electron and form positive one ions. They are stored in kerosene and oil. Why? Because they are highly reactive. They can easily react with air, oxygen in the air, or moisture in the air, and can cause an explosive reaction. They are soft, silvery, and shiny, but you must have seen that the metals at times look dull. The reason for that is they react with oxygen in the air, as they're too reactive, and forms a layer of oxides on its surface, and that oxide give them a tarnish appearance. And I've already told you that lithium is less reactive and francesium is highly reactive. They have low melting in the boiling points, and the melting and the boiling point decreases down the group. Okay, so I hope these physical properties are clear to you. Now let us look at the chemical properties. Now in the chemical properties, you need to know about three reactions: reactions with water, reactions with oxygen, reaction with halogen. Now always remember, whenever asked in the exam, you'll be writing a balanced chemical equation along with the state symbols. So here I'll be taking an example of lithium, how lithium reacts with water, oxygen, halogen. You can replace lithium with any of the group 1 element, that is lithium, sodium, and potassium, and write the equation the same way. So whenever any metal, that is M, group 1 metal, that is lithium, sodium, and potassium, reacts with water, it forms metal hydroxide. MOH is the formula, plus hydrogen. So if I take M with lithium, lithium with water form LiOH plus hydrogen. Remember, lithium is a solid, water is a liquid, lithium hydroxide is aqueous, and hydrogen is a gas. Now the question can come, what is the observation of this reaction? So you can easily say that we will see that the solid is decreasing in size or mass. And since there is a hydrogen being produced, which is a gas, we'll see the fizzing. Okay, and they can ask you the test for hydrogen. So it's a squeaky pop test. Okay, so metal hydroxide is formed, which is an alkali, and therefore they can ask you what will be the pH. So there'll be an increase in pH. And remember, the reactivity increases down the group. So potassium will react more violently as compared to lithium. When we see the reaction with oxygen, it forms metal oxides, and for the group 1 oxide, the formula is M2O. So lithium oxide is Li2O, sodium oxide is Na2O. We'll see in bonding how we determine the formulas of the ionic compound, but till then you can just remember that group 1 oxides will be of the formula M2O. So lithium, which is a solid, reacts with oxygen, which is a gas, and it forms 2Li2O, which is a solid. Okay, and when we react it with halogens, you get the metal halides. Okay, so like lithium with fluorine, remember halogens will be in the form of diatomic molecule, and it gives lithium fluoride, which is a solid. Okay, so these three reactions, very, very important. Make sure you remember them. Make sure you know how to write the equations along with the state symbols, and do not forget to balance the equation. Okay, now, as you know, the reactivity with the water will increase down the group. So when you have the reaction with potassium, we will see that there's a fizzing, and there's a very violent fizzing, and the potassium will quickly melt into a ball and catches fire and produces a lilac flame. Whereas sodium will react a little bit intermittently, and all of them, lithium, sodium, potassium, as I told you, alkali metals have less density. We'll see both of them will be floating in water. Okay, all of the three will be producing fizzing because the hydrogen is being released. In lithium, since it is not that reactive, the shape is retained and it quickly, slowly gets smaller. Whereas in sodium, it melts into a ball while reacting. So it will get deformed earlier than lithium. And potassium, it quickly melts into a ball, catches fire, and produces a lilac flame. This observation can also tell you that the one that is reacting very explosively is one of the elements which is down the group. Okay, so I hope the physical properties, the chemical properties, and what is the electronic configuration of group 1 is clear to you. Now comes a very important question. Why the reactivity of group 1 increases down the group? Okay, now, in order to explain that, you need to remember that if any question comes in, you need to first explain that alkali metals, they react by losing electron, and the tendency to lose the electron increases down the group, therefore they become more reactive. Now the question is, why it increases down the group? Now, the tendency to lose an electron depends on these three factors. And all these three factors contributes to an increase in tendency of the alkali metals to lose an electron down a group. First is the nuclear charge. Now, if the nuclear charge will be smaller, the outer electron will be weakly held by the nucleus and can be lost easily. So once we go down the group, you have seen, if you see the electronic configuration of the group 1 elements, can you see that the shells are increasing? So there are more electrons that are being added. So the atom is getting bigger in size. As the atom is getting bigger in size, the outer electron is getting further away from the nucleus. So as the outer electron is getting further away from the nuclear charge decreases. The inner electrons, they are shielding the outer electron from whatever nuclear charge that is present, and bigger the size of the atom is also decreasing the nuclear charge. So due to all these factors, down the group, the tendency to lose an electron increases, and alkali metals react by losing an electron. Therefore, the reactivity of group 1 increases down the group. Okay. Now remember, when you get this question, you need to talk about these scientific terms, the nuclear charge, shielding, and size of the atom. Okay, so I'll summarize. Down the group, the atom size increases due to increase in the number of electronic shell. This results in the outer electron being further away from the nucleus. As the outer electrons become further away from the nucleus, the nuclear charge decreases. Increase in number of shells also increases the shielding and shields the outer electrons from the nuclear charge. Therefore, the tendency of an atom to lose an electron increases down the group, resulting in increase in reactivity down the group. Okay, so remember, in group 1 you need to know the reason why it increases, the reactivity increases down the group, and I hope now you're able to answer that. Okay, now the next thing we need to do is group 7. As I told you, group 7 are known as halogens, and halogens are known as salt forming. Okay, now what is the electronic configuration of halogens? So electronic configuration is that they all have 7 electrons in its outermost shell, and when they have 7 electrons in this outermost shell, they can easily gain 1 electron to gain the full outer shell configuration. And when they gain these 1 electron, what will happen? They will form the -1 charge. So these all react by forming the -1 ions. So the members of the halogens are fluorine, chlorine, bromine, iodine, and astatine. Electronic configuration 27, 287, 2818, 7, 288, 1887. So you can see all of them have 7 electrons in this outermost shell. Now you also need to know what is the physical state, like how do they look like at room temperature and how do they look like in solution. So the fluorine is a yellow gas, chlorine is a green gas, and if fluorine is in solution, that if there's any reaction that results in the formation of chlorine in a solution, then it will give a pale green color. Bromine is a volatile brown liquid, but if bromine is in the form of bromine water, it will be yellow colored solution. Iodine is a volatile purple solid, but if it is in solution, it will form a brown solution. And astatine is a radioactive halogen. Again, as we discussed in group 1, the group 7 has an opposite trend in reactivity. So group 7 reactivity decreases down the group. Why? Because they react by gaining an electron and the electron affinity decreases down the group. Okay, we'll see it in detail in the next 2 to 3 slides why it happens. But if the question comes in the exam, which is the highly reactive halogen, so you should quickly answer fluorine, which is the least reactive, astatine, which is more reactive than bromine, chlorine, which is less reactive than bromine, iodine, which is a green gas amongst halogen, chlorine. So you should know about all of this. Okay, so now let's talk about the physical properties. We all know they are nonmetals, found to the right. They gain an electron from -1 ions. They have low melting and a boiling point, and their melting points and boiling point increases down the group. I already told you they exist as diatomic molecule. They're poisonous and smelly. Their reactivity does not increase down the group. The reactivity decreases down the group. Their density increases down the group, and they are poor conductors of heat and electricity. Okay, now let's talk about their chemical reactions. When they react with hydrogen, they form hydrogen halide, and these hydrogen halides, if you have a fluorine, chlorine, the reaction will be more explosive because these are highly reactive. Down the group, to react, have this reaction with iodine or maybe bromine, you might require a catalyst. When they react with metals, they form ionic compound. They gain one electron from the metals and form this noble gas electronic configuration. These ionic bonding will be discussed in more detail in the structure and bonding unit. Okay, now this is a very, very important reaction, which is a displacement reaction. And this is the only reactions in halogen which require a bit of an understanding. It's easy if you understand it properly. Now, what happens is a more reactive halogen will take the position of the less reactive halogen in its salt. Okay. Now, what is the most reactive halogen? The halogen which is at the top will take the position of the halogen at the bottom, provided the bottom halogen should be in the form of a compound. So, for example, if you look at this reaction, chlorine with NaBr, which is more reactive? Chlorine, good. Which is less reactive? Bromine. And bromine is in the form of compound or salt. So chlorine can quickly swap the position of the bromine and form 2NaCl and displaces the bromine. And if you remember, if this reaction is in solution, you will see a yellow solution. Okay, so chlorine is being more reactive. The salt is of the less reactive halogen. So chlorine being more reactive has taken the position of the less reactive bromine in its compound, and bromine gas being less reactive than chlorine has been displaced by chlorine. On the other hand, if you do this reaction, chlorine with NaF, which is more reactive? Fluorine, is it alone? No, it is in the form of compound. So nobody can take its position because it is the highly reactive, so no reaction. So fluorine can displace all the halogens, chlorine can displace all except fluorine, bromine can displace only iodine, and iodine cannot displace fluorine or chlorine or bromine. Okay, so remember, the top halogen can take the position of the bottom halogen, provided the top halogen should be alone and the bottom halogen should be in the form of an element or a compound. Okay, sorry, compound or in the form of a salt. Okay, so I hope this displacement reaction is clear to you. Next is, again, as group 1, why the reactivity of group 7 increases down the group. So to answer this question, you will first explain how group 7 reacts. So group 7 reacts by gaining electron, and down the group, the electron affinity decreases. Therefore, the reactivity down the group decreases. Now, why the tendency to gain an electron decreases? Again, we'll be talking about these 3 scientific terms: nuclear charge, shielding, and size of the atom. As you go down the group, the nuclear charge decreases because of the increase in size of the atom. So the halogen cannot hold the incoming electron properly. So it won't be able to gain an electron with that ease down the group. Also, down the group, the nuclear charge gets shielded by the inner electron. So the incoming electron will experience a smaller nuclear charge. Okay, so I hope it's clear to you. Now let me summarize. Down the group, the atom size increases due to increase in the number of electron shell. As a result, the nuclear charge decreases. The size of the atom also increases down the group, which makes the nuclear charge weaker. The electron shells also increases, which decreases the effective nuclear charge on the incoming electron. So due to all these factors, the nuclear charge decreases, which decreases the tendency of gaining electron down the group of halogen, making them less reactive. Okay, so to summarize, we talked about group 1, group 7. These are alkali metals, these are halogens. They have 1 electron in their outermost shell, they have 7 electrons in their outermost shell. They are metals, they are non-metal. They react by losing an electron, they react by gaining an electron. They form positive 1 ion, they form negative 1 ion. The alkali metal reactivity increases down the group, and the group 7 halogen reactivity decreases down the group. The group 1 reactivity depends on the tendency to lose an electron, and group 7 halogen tendency depends on gaining an electron. Therefore, reactivity of group 7 decreases down the group, but for group 1, it increases down the group. Okay, now let's do the last topic, transition metal, which is a chemistry only topic. Transition elements are found in group 2 and 3. So this block is a transition metal. They are hard, they are strong, they are malleable and ductile. They have higher density than group 1 and group 2. Therefore, iron you have seen, copper you have seen is used in construction purposes. They are used commercially as a catalyst. They show variable oxidation state. They form colored compounds, okay? And they show the reaction of oxygen, water, and halogen like group 1, but they react slowly, so they do not corrode easily, okay? So I hope the periodic table is clear to you. Now let's quickly brush up the key terms that we saw in this unit. We discussed about the periodic table, metals, non-metal, halogens, alkali metal, noble gases, transition metals, periods, group, alkali, and the displacement reaction. Now, what is a periodic table? A periodic table is a table that shows an arrangement of all the known elements in the order of their increasing atomic number or a proton number. And the table is organized into periods and groups. Metals are the elements found in the left of the periodic tables, which are sharp, shiny, conductors, malleable, and ductile. Example, group 1, 2, and group 3. Non-metals are the elements found to the right of the periodic table, which are dull, insulators. Example, group 4, 5, 6, and 7. Halogens are group 7 elements as they are salt forming. Alkali metals are group 1, which react with water to form alkali. Noble gases are group 0 elements, which are stable and do not react as they have complete outer shell. Transition metals are the elements found between group 2 and group 3, which have high density, show variable oxidation states, and form colored compounds. Periods are the horizontal rows of the periodic table. Groups are the vertical columns of the periodic table. Alkalis are the bases that are soluble in water. And displacement reaction is when a more reactive element displaces the less reactive element from its salt solution. Okay, so all these key points are clear to you. Now let's test yourself. Now you need to look at the periodic table and give me 2 examples of each. A non-metal, alkali metal, halogens, noble gases, semi-metal or metalloid, metal that form +1 ion, metal that form -1 ion, metal that form +2 ions, and a transition metal. Next is you need to write the name of the most reactive halogen and the most reactive alkali metal. Why alkali metal gets more reactive down the group, why the halogen gets less reactive down the group, and then you have to write the balanced chemical equation, including the state symbols of potassium with water, lithium with oxygen, sodium with bromine, chlorine and hydrogen, and then you need to explain the displacement reaction of halogen with example. So you can pause the video, have a go at these questions. If there's still any question you're unable to answer, go back, look over the video again. Okay, so now let us look at the answers. So metal, these are just my answers. You can pick any. So there's no right and wrong here. Metal, there are so many metals. You can list any metal. But remember, they should be from the left of the periodic table. Non-metal, oxygen, fluorine, alkali metal, group 1, halogens, any metal from group 7, noble gas, group 8, semi-metal or metalloids, remember that zigzag, all the elements that come in the zigzag, you can name that, so that is silicon. Metal from +1 ion, it means they have 1 electron in the outermost shell, so any of the group 1 example. Non-metal that form negative ions means it should have 7 electrons in the outermost shell, so any of the halogen. Metals that form +2 ions should be group 2, so any of the group 2 you can name. Transition metals are the elements between group 2 and group 3, so you can give any example from that. Okay, so I hope you are now clear with how to read the periodic table. The most reactive halogen, remember, is the halogen which is the top one, that is the fluorine, and the most reactive alkali metal is the bottom one, which is the francium. Why the alkali metal goes more reactive down the group? I know you know the answer. So down the group, the atomic size increases due to increase in number of electronic shell. This results in the outer electron being further away from the nucleus. As the outer electron becomes further away from the nucleus charge decreases. Now, increase in number of shell also increases the shielding and shields the outer electron from the nuclear charge. Therefore, the tendency of an atom to lose an electron increases down the group, resulting in increase in reactivity of the alkali metals down the group. On the other hand, halogens down the group, the atomic size increases, again due to increase in number of shell. The nuclear charge decreases, the size of the atom also increases, decreasing the nuclear charge, and the shells also shields the outer electron from the nuclear charge. Therefore, the incoming electron cannot be held with a stronger nuclear force. Due to all these factors, the tendency to gain an electron or electron affinity decreases down the groove. Therefore, the halogens become less reactive down the groove. Okay. Next is write the chemical reaction, potassium with water, KOH plus hydrogen. Remember, there'll be a fizzing. It's an alkali, so the pH increases. Lithium with oxygen is lithium oxide. It can form the layer and make the metal look dull. Sodium with bromine is a sodium bromide, ionic compound. We'll see dot and cross diagram in the bonding chapter. Chlorine with hydrogen form an HCl gas. Explain displacement reaction when the more reactive halogen displaces the less reactive from its salt. So fluorine being more reactive is alone can displace the less reactive which is in the compound and itself form a compound and displaces the other one, so that is chlorine. But if we do it in the other way around, chlorine being less reactive cannot take the position of NaIF, so no reaction. Begin. Now if you remember from the periodic table video, we talked about that in our periodic table we get metals to the left and non-metals to the right. Now, bonding is divided into three: ionic, covalent, and metallic. Why do elements bond or atoms bond? They bond to gain full outer shell or noble gas electronic configuration. And they do so by three ways: either by transfer of electron between a metal and a non-metal. So that is ionic bonding, which is between metals and non-metals. Covalent bonding is the sharing of the electron between two nonmetals, and metallic bonding is between the metals where there's an electrostatic force of attraction between fixed positive ions and delocalized electron. So if any formula is given to you, you can easily say whether it is an ionic and covalent bonding, seeing what atoms are bonded. So if in carbon dioxide there's carbon and oxygen, which are found to the right side of the periodic table, they are two nonmetals, so that is covalent. Ammonia is nitrogen and hydrogen, which are again two nonmetals, so that is covalent. Nitrogen is nitrogen, which is covalent. Water is covalent. Sodium chloride is sodium, which is to the left side, and chlorine, which is to the right side. So this is ionic. Calcium fluoride is ionic. So just by looking at the formula, you can also say whether it's ionic, covalent, or metallic bonding. Now, what is ionic bonding? Ionic bonding is between a metal and a non-metal, and you should understand how you draw the dot and cross diagram. So in dot and cross diagram, you do three things. First of all, write the elements and write their electronic configuration and write their outer, just draw their outer electron. So aluminium is 283, fluorine is 27. So in aluminium, I've drawn 3 electrons with a dot or a cross, or the other one with a dot or a cross, and then I'll choose 7 electrons. Now, aluminium has to get rid of 3. So 1 electron from an aluminium goes to fluorine because fluorine just needs 1. But that makes aluminium to lose 2 more. So it takes the help of 2 other fluorine. So you'll draw the outer electron, show the arrow. So first write the symbol, write the electronic configuration, show the outer electron, show the transfer. And then write the charges. As aluminium has lost 3 electrons, it has got 3 plus charge, and fluorine has got 1 minus charge, but there are 3 fluorines. And this is how you need to draw the dot and cross. Remember, write the electronic configuration, show the outer electrons, and show the transfer. Okay, now whatever we have drawn, we'll write that in a definition. So ionic bonding is between a metal and a non-metal. The metal is losing an electron to a non-metal, and as metal is losing an electron, it is getting a positive charge. Non-metal gains an electron and becomes a negative charge, and there's an electrostatic force of attraction between an opposite charge ion, resulting in ionic bonding. So metal loses an electron and becomes positively charged. Non-metal gains an electron, becomes negative charge, and there's a strong electrostatic force of attraction between opposite charge ion, resulting in ionic bonding. So I hope this dot and cross diagram is clear to you. Now let us take another example of magnesium and chloride, magnesium chloride. So I'll write the first electronic configuration. Magnesium is 282, chlorine is 287. Then I'll draw the outer electron. For the outer electron, my magnesium, I'll show 2 electrons, and chlorine, I'll show 7 electrons. So that's my next diagram. Magnesium, I'll show 1, 2 electrons. Chlorine, I'll show 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Magnesium will be losing 1 electron to chlorine. Magnesium has to get rid of 1 more, so it will take another help of the chlorine. And then what will happen at the end, magnesium has lost 2 electrons, will have a +2 charge. Chlorine has 7 electrons, 1, 2, 3, 4, 5, 6, 7, and a dot with a -1 charge, and there are 2 chlorines. So ionic bonding is between metal and non-metal. Metal loses an electron, remember, and becomes positively charged. Non-metal gains an electron and becomes negatively charged. There's a strong electrostatic force of attraction between opposite charge ions, resulting in ionic bonding. Next is, you should know what are the properties of the ionic compound. They are brittle solid with definite crystal shape. They are good insulators in solid forms but becomes good conductors. This is very important in liquid or dissolved form. High melting and a boiling point compared to the molecular bonds. Now the reason for these properties you should know. So in ionic compounds, there's a strong electrostatic force of attraction between an opposite ions. This results in the formation of giant ionic lattice. Now, why it is a conductor in a liquid form? In solid form, the ions are not free to move as they are held together by strong electrostatic force of attraction. In molten or when they are dissolved in water, the ions are free to move and conduct electricity. And why they have a high melting and a boiling point? Again, because there's a strong electrostatic force of attraction between opposite charge ions. It forms a giant ionic lattice. So large amount of energy is required to overcome these strong electrostatic force of attraction. Therefore, they have a high melting or a boiling point. Okay, so this is how you explain the properties of ionic compounds. However, if I asked you to compare whether aluminium chloride, magnesium chloride, or sodium chloride, which one will have a greater melting point, it depends on charge. Greater the charge, strong will be the electrostatic force of attraction. And remember, aluminium forms 3+, magnesium forms 2+, sodium forms +1. So since aluminium has a greater charge, it will have a stronger ionic lattice. So aluminium chloride will be more stronger as compared to magnesium chloride as compared to sodium chloride. Okay, so I hope this is clear to you. Now next is how to write the ionic formulas. To write the ionic formulas, the step is you write the symbol, write the charges. Up to group 4, the charge is same as the group number. After group 4, it is group number, take away 8, and then do crisscross. For example, if I gave calcium and calcium oxide. Now, write the symbol, so that is Ca. Oxygen, calcium is in group 2, so charge is 2+. Oxygen is in group 6, so 6 minus 8 gives a 2 minus charge. Since both charges are same, they get cancelled, so the formula of calcium oxide is CaO. Sodium oxide, sodium is in group 1, has a +1 charge. Oxygen is 6, 6 minus 8 is 2 minus, then you crisscross, 2 of oxygen comes underneath sodium and 1 of sodium come underneath oxygen. Remember, it's the numbers that get crisscrossed. Generally, we do not write 1, so the formula would be Na2O. Then work out magnesium nitride. Magnesium is group 2, so that is 2+. Nitrogen is group 5. 5 take away 8 is -3. And then you do crisscross. 3 of nitrogen comes underneath magnesium. 2 of magnesium come underneath nitrogen. So this is Mg3N2. Okay, so please try all of them, and then you should get sodium sulfide to be Na2S, sodium chloride to be NaCl, magnesium chloride to be MgCl2, and aluminium chloride to be AlCl3. Okay, now these are all the symbols that you can get from your periodic table. However, there are some complex ions which you do not get from the periodic table. You need to remember their charges. I have tabulated this for you here. Make sure you remember them. If you're finding hard to remember, put it on your study room, see it every day, and you will memorize them. Ammonium is NH4+, hydroxide is OH-, carbonate is CO3-2-, sulfate is SO4-2-, nitrate is NO3-, phosphate is PO4-3-. Now magnesium hydroxide, you know Mg is group 2, so that is 2+. Hydroxide is OH from -1, you crisscross. Remember, in the complex ion, you have to draw the bracket because it's the OH that gets 2. So the formula would be MgOH2. What is the formula of aluminium sulfate? Aluminium is 3+, SO4 is 2-. We do the crisscross. Aluminium will get the 2 of sulfate, so it will be Al2. The whole sulfate gets a 3 number. So you put SO4 entire in a bracket and you write 3. Okay, so in this way you can get calcium phosphate as Ca3, PO4-2. Magnesium nitrate is MgNO3, which is 2. calcium carbonate is CaCO3, and sodium phosphate is Na3PO4. So I hope how to work out the formulas of ionic compounds with complex ions is clear to you. And ionic bonding. Now let's move on to covalent bonding. It is between two nonmetal. It shows the sharing of electron. More than one electron pair gets shared, it will become double or the triple bond. Now what you do is you draw the circle, draw the outer electrons, one with the dot, one with the cross, and see how much electrons both needs to gain full outer shell and share that in the middle. For example, hydrogen has one, needs one more, so you put one electron at the center. Chlorine also needs one, so you put one chlorine electron at the center and draw the rest on the rings. Chlorine each need one, so you draw one electron of each at the center and make the rest. Water, between an oxygen and hydrogen, there's a sharing of one electron each. Nitrogen and hydrogen, between each of these circles, sharing of one electron. Carbon and hydrogen, one electron each. But nitrogen both needs three electrons to complete the full outer shell, so you draw 3 electrons in the center. Similarly, oxygen needs 2 electrons, so you draw 2 at the center. Carbon, oxygen, you draw 2 each at the center. So oxygen is a double bond. Carbon and oxygen is a double bond. Nitrogen and nitrogen is a triple bond. Okay, so I hope these dot and crosses are clear to you. Please make sure you understand them because they are often asked in the exam. Okay, now since we have done covalent compounds, we should know the properties of them. Covalent compounds are classified into simple molecular and giant covalent. Simple molecules are oxygen, chlorine, and methane. They have weak intermolecular forces between them, therefore they have low melting and a boiling point. However, their intermolecular forces increases with size, so therefore polymers which have covalent bonding between them, high melting and a boiling point due to their chain length. Whereas diamond, graphite, and silicon dioxide are the examples which have a giant covalent structure, therefore they have strong melting and a boiling point. Now ionic compound, let's compare the difference between ionic and the covalent compound. Ionic compounds are crystal, covalent are solid, liquids, and gases. Ionics have high melting and a boiling point, covalent have lower melting and a boiling point. Ionics are hard and brittle, covalents are poor conductors. Ionic usually are soluble in water, covalent are not. Ionic undergo electrolysis and covalent are flammable. Okay, so now let us see the giant covalent structure, diamond and graphite. This is the difference between them. Diamond has a hard, rigid structure, whereas graphite has a layered structures. So diamond is hard, has a high density. Graphite is soft and greasy, lower density. In graphite, 3 electrons are bonded to form a ring and 1 electron is localized for each carbon. These delocalized electrons make it a good conductor. So diamond is an insulator, graphite is a conductor. In diamond, each carbon atom is covalently bonded to 4 other carbon, giving it a strong rigid structure. In a graphite, carbon atoms are bonded in the form of layer, in the form of hexagon. No covalent bonding between the layers, so they can easily slide past each other. And each carbon is bonded with 3 other carbon, leaving the 4 electron delocalized. So diamond has no delocalized electrons used in cutting or in jewelry. Graphite has delocalized electrons. It is used in pencil lids. Okay, so I hope the structure of diamond and graphite is clear to you. Now they can ask you this question: why graphite is tough and slippery, or why graphite conduct electricity. So in graphite, carbon atoms are bonded in the form of layers, in the form of hexagon. No covalent bondings are between the layers, so they slide past each other. The layer have only weak intermolecular forces between them. So by applying a little pressure between the layers, they can slide past each other, making graphite soft and slippery. On the other hand, in graphite, carbon atoms are bonded in the form of layer, in the form of hexagon. No covalent bonding is present between the layers, so they slide past each other. Each carbon atom is bonded with 3 other carbon, leaving the 4th electron as delocalized. And these delocalized electrons are mobile electrons which move and conduct electricity. Okay, then there are other 2 allotropes of carbons which are there in your syllabus. It's a fullerene, which is a hollow shaped molecule having hexagonal rings like a buckyball, also known as Buckminster fullerene. Carbon can be in the form of pentagon or the hexagon ring, and it is used as catalyst, drug delivery, or treating cancer. Graphite is a layer of interlocking hexagonal ring like a shingle sheet of graphite. It is light, rigid, 100 times stronger than steel, perfect thermal conductor. It is a better conductor than graphite, light and have low density. Therefore, it is used in making copper chips, computer chips, and flexible electronic display. Okay, and then we have carbon nanotubes, which looks like this. They are cylindrical fullerene with the length greater than the diameter. They have a high tensile strength, so they are used in making reinforced composite materials, and they have a high electronic conductivity, therefore used in electronic conductivity or industries. Now comes the last bonding, which is the metal. It is between two metals. You can see they are fixed positive ions in the sea of delocalized electrons. There are layered structure forming a giant lattice, and there's a strong intermolecular forces, strong electrostatic forces between the opposite charge ions and the delocalized electron, resulting in metallic bonding. You should be able to draw this diagram and explain these points. Fixed positive ion, delocalized electron, as you have a lot of properties on the basis of them. So what are the properties? Metals are malleable. What is the meaning of malleable? They can be hammered into any shape. Metals are ductile, means they can drawn into wires. They are good conductors of electricity, and they have high melting and a boiling point. So why metals are malleable? Because the metals have layered structures. They can slide past each other just by little hammering. Ductile, again, because they have layered structure, they can be hammered. They are good conductors of electricity because there are mobile electrons. There are delocalized electrons which can conduct electricity. And due to strong electrostatic force of attraction between fixed positive ion and delocalized electron, they have high melting and a boiling point. Next is a very important concept of an alloy. You can see this is a pure metal having a layered structure. When you mix it with another metal or a non-metal being different in size, it interlocks these spaces so the metals can no longer slide over each other. Example, steel is the alloy of the iron, which is more strong and resistant to corrosion. So in metals, the particles are arranged in layers. There's a regular arrangement of fixed positive ions which can slide over each other by applying pressure. However, in alloys, there's a mixture of metal with another metal or a non-metal. Another metal being different in shape and size distort the regular arrangement of the metal ion. As a result, the layers can no longer slide past each other, making a metal strong. Next, you have a concept of nanoparticles. These are the particles that are size 1 to 100 nanometer. Now, 1 meter is 10 to the power 9 nanometer. Okay, so 1 nanometer is 1 times 10 to the power minus 9 meters. Now, how do we get to know to this calculation? You need to remember this chart. It's killing metal Milo Mickey nano pictures. km, milli, micro, nano, picometer, and all of them are 10 to the power 3. So from kilometers to meter, you time by 1000, meters to millimeters, times by 1000, and when you go reverse, you divide by 1000. So if you need to convert the nanometer into meter, so you go from here to here, there are 3 bumps, so you divide it by 10 to the power 9. So 1 nanometers is 10 to the power minus 9 meter. For example, convert 10 nanometer to meter. So nanometer to meter is divided by 10 to the power 9. So 10 divided by 10 to the power 9 is 10 to the power minus 8 meter. Convert 10 nanometer to micrometer. So now let's see how you do that. 10 nanometer is here, micrometer is here. They both have divided by 10 nanometer to micrometer. So this is a 10 nanometer, this is millimeter. So if you are converting 10 nanometer to a millimeter, you divide it by 6. So that becomes 10 power minus 5 meters. So I hope this is clear to you. Now, why nanoparticles are important? Because as the size decreases, the surface area to volume ratio increases. Therefore, nanoparticles being very small size have large surface area to volume ratio, making them very useful in science and medicine. You can see if you have a cube of 1000 meters, its surface area would be 6 times 1000 by 1000, which is 6 times 10 power 6, and volume would be 10 to the power 9. So surface area to volume ratio is 6 times 10 power 3. On the other hand, when you have 100, then the surface area to volume ratio is 6 times 100. So with an decrease in size, surface area to volume ratio increases. Therefore, nanoparticles are very important, being having high surface area to volume ratio. So, as we have seen that the nanoparticles have high surface area to volume ratio, they have a variety of uses. They're used in medicines for drug delivery or to kill cancer and tumor cells. They're used in cosmetics, they're used in sunscreen to block sunlight. They're used in household as self-cleaning window panes. The nanoparticles are coated with materials. When light falls in them, they carry out a reaction and breaks the dirt, and which is washed away by water while raining. And being having lots of area to volume ratio, they are used in small quantities, so they are very effective as a catalyst. However, there are a lot of risks of nanoparticles due to small size. They can cause difficulty in breathing. They can accumulate in the environment and cause air pollution. Due to their large surface area, a small spark can result in violent explosion, making them risky to use. They're toxic and cause breathing and respiratory problems. Due to their small size, they can also cause water pollution and risk the aquatic life. Okay, so I hope all these types of bondings with their properties are clear to you. Now, there are 3 states of matter, which is there in your syllabus. I think you must have remembered from your key stages. 3, 4 particles in solids are closer together, have fixed shape, strong forces between the particles, definite volume, cannot be compressed and cannot flow. On the other hand, liquids are slightly closer, do not have fixed shape, there's weak forces between the particles, have fixed volume, can be compressed and can flow. And gases, the particles are far apart, do not have fixed shape, they have weak intermolecular forces, do not have fixed volume, highly compressibles, and can flow. So you can see solid particles are very closer to each other. Liquid, they are little far apart. In gas, they are very far apart. And solid can be converted to a liquid by melting, reverse freezing. Gas can be converted to a liquid by condensation, and liquid can be converted to a gas by evaporation. Okay, now this is the curve that whenever you increase the heat, the solid temperature is heated, and at the melting point, the temperature remains the same until all the solid converts into a liquid. Then when the change of state happens, the material, the temperature increases, then the liquid converts into a gas, and at a boiling point the temperature remains the same until all the liquid converts into a gas, and then at boiling it converts into a vapor. Okay, so I hope all these terms, all this topic is crystal clear to you. Now there's a time for the key terms we have seen in this topic. Okay, so now let us revise what are all the key terms that we did in this topic. So we talked about ions, ionic bonding, dot and cross, covalent bonding, metallic bonding, intermolecular forces, joint covalent molecules, polymers, delocalized electrons, fullerene, graphenes, alloys, nanoparticles, nanoscience, states of matter, solid, liquids, and gases. Ions are the charged atoms with unequal number of protons and electrons. Ionic bonding is between metal and a non-metal, which involves transfer of electrons between a metal and a non-metal. Dot and cross is a diagram that shows transfer of electrons in an ionic bond or sharing of electrons in a covalent bond. Covalent bonding is the bonding between two non-metals, which involves sharing of electron. Metallic bonding is a bonding between fixed positive ions and delocalized electron. Intermolecular forces is the forces between the molecules which determines the melting or boiling point. Giant covalent molecules are the covalently bonding molecules with a giant structure. Polymers is made up of many repeating units. Delocalized electrons are the mobile electrons which are free to move. Fullerenes is an allotrope of carbon which form a cage-like structure like buckyball. Graphene is the allotrope of carbon which is equivalent to single layers of graphite. Alloys are the mixtures of metal with another metal or a non-metal. Nanoparticles are the particles which are the size 1 nanometer to 100 nanometer. Nanoscience is a branch of science that deals with nanoparticle. States of matter are different form of states that a matter can take, solid, liquids, and gases. Solids are the states of matter with fixed shape and volume. Liquids are fixed shape but not fixed volume. Liquids and then states of matter without any fixed shape and fixed volume is the gases. Okay, so I hope this is clear to you. Next is test yourself. So you need to show the name type of bonding in sodium chloride, magnesium, nitrogen, carbon dioxide, water, and ammonia. Draw dot cross diagram to represent sodium chloride, water, and magnesium. Differentiate between diamond and graphite. Why ionic compounds do not conduct electricity in solid. Why alloys are stronger than metals. Why aluminium has strong melting point than sodium, and what are nanoparticles, give its properties and application. Okay, so sodium chloride is ionic, magnesium is metallic, nitrogen is covalent, carbon dioxide is covalent, water is covalent, ammonia is covalent. Dot and cross diagram, sodium chlorine, you will see 281, 287. Transfer of electron from sodium to chlorine, sodium will get +1 and chlorine will get -1. For magnesium, there's a fixed positive ion in the sea of delocalized electron, and charge of magnesium is 2 plus, so you will put 2 plus. Difference between diamond and graphite: it's hard, insulator, high density. Each carbon is covalently bonded to 4 other. No delocalized electron used in cutting or jewelry. Graphite is soft and greasy, conductors, lower density than diamond. Carbon is bonded in the form of flare, in the form of hexagon. It has delocalized electron used in pencil leads. Why ionic compounds do not conduct electricity in solid? Because in solids, the ions are not free to move. Alloys are stronger than metals because the different size atoms, it distort the regular arrangement, so they cannot slide past each other. Aluminium has stronger melting point than sodium because of its greater charge. It has greater charge, greater number of electrons, so greater charge density, so stronger electrostatic force of attraction. Nanoparticles are the particles of size 1 to 100 nanometer. Due to smaller size, they have high surface area to volume ratio, making them useful in medicine, catalyst, cosmetics, and industry. Okay, so I hope this topic is clear to you. The next step, as always, check the specification, do exam style questions on this topic. All these notes along with exam style question can be found on my website. The link is shared in the description box below. If you have any problem, leave a comment below. We'll reply you as soon as possible, or you can come to our website. There's a 24/7 chat support till your exam to answer all your queries. You can ask anytime. Okay, so I hope you like this video. Do not forget to subscribe to our channel, and do like, comment, and share this video. Do not forget to click on the bell icon so that you can get the notification of all the latest and useful videos I make before your exam. And if there's any specific topic you want me to make a video on, then do leave a comment. I'll make sure I'll put that up before your exam. Okay, so I'll see you next in the next video. Till then, happy revising.